Hello everyone, my presentation this time is about solving problems involving probability of the union of mutually exclusive events. Example number 1, what is the probability of drawing a jack or a 10 from an ordinary deck of cards? So again, this type of problem is probability of mutually exclusive events. So here, you should have the knowledge of the number of cards in the play cards. So here is the table of the number of cards per suit, per value, and the rest. So here, let us count how many are jack here. So there are 4. And there are 52 cards in all. Our first fraction is 4 over 52. 4 because there are 4 jacks, and over 52 because there are 52 cards in all. And then so we have to add, plus 10 from an ordinary deck of cards. So how many 10 cards do we have? So there are 4 cards again. Tens. There are 4 tens. So plus 4 over 52. Solving this is equal to 4 plus 4 is 8 over 52. And then reduce to lowest term, divide both by 4. 8 divided by 4 is 2. 52 divided by 4 is 13. So the probability is 2 over 13. Next, example number 2, a box contains 3 red balls, 4 green balls, and 5 blue balls. If a ball is drawn, find the probability of the following. So before we answer, let us identify first how many balls in all. So of course, simply add 3 red balls plus 4 red balls plus 5 blue balls is equal to 12. Let's proceed. Letter A, a red or a green ball. So there are 3 red balls over 12. Then plus green, there are 4 over 12. Then add 3 plus 4 is equal to 7, copy 12. 7 over 12 is already in lowest term, so 7 over 12 is the final answer for letter A. This is the probability of getting a red or a green ball out of the 12 balls. Next, letter B, a red ball again, so 3 over 12, or a blue ball plus 5 over 12, there are 5 blue. Then add 3 plus 5 is 8 over 12 equals, reduce to lowest term, 8 divided by 4 is 2, 12 divided by 4 is 3. So the answer is 2/3, or 2/3 is the probability of getting a red or a blue ball. And letter C, a green. There are 4 green balls, so 4 over 12, plus a blue ball again, plus 5 over 12. Then add 4 plus 5 is equal to 9 over 12. Reduce the lowest term, divide by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So the answer is 3/4, or 3/4 is the probability of getting a green or a blue ball. Next, example number 3, a pair of dice is rolled. What is the probability of getting a sum of letter A, 6 or 8, letter B, a double or sum of 5? Let us first determine the sample space. The sample space is 36. Why 36? Because one die has 6 faces, and you have to roll 2 dice, so that's 6 squared, and 6 times 6 is 36. Therefore, 36 is the sample space. Now, let's answer letter A. What is the probability of getting a sum of 6 or 8? First, let's determine the number of pairs for sum of 6. We have 1 plus 5, 5 plus 1, 2 plus 4, 4 plus 2, and 3 plus 3. So there are 5 pairs in all. So that's 5 over 36. So 5, because there are 5 pairs of sum of 6, over 36 is the sample space. So 36 is always the denominator all throughout the solutions. Next, sum of 8, we have 2 plus 6, 6 plus 2, 3 plus 5, 5 plus 3, and 4 plus 4. So there are 5 pairs in all. That's plus 5 over 36. Now let's add 5 plus 5 is 10, copy 36. Then reduce the lowest term, divide both numerator and denominator by 2. So 10 divided by 2 is 5, 36 divided by 2 is 18. 5 over 18 is the probability of getting a sum of 6 or 8. Now let's proceed to letter B, probability of getting a sum of a double or sum of 5. For a double, we have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. There are 6 pairs in all, so that's 6 over 36. Now, for sum of 5, we have 1 plus 4, 4 plus 1, 2 plus 3, and 3 plus 2. There are 1, 2, 3, 4 pairs, so that's plus 4 over 36. And then, solve this. 6 plus 4 is 10. Copy 36. Reduce the lowest term, divide by 2. So 10 divided by 2 is 5. 36 divided by 2 is 18. The probability of getting a sum of a double or sum of 5 is 5 over 18. That's all about the different examples involving probability of mutually exclusive events. Next time, we're going to have probability of not mutually exclusive events. So for now, thank you for watching.